In this example, we have to expand this product in ascending powers of x up to the term in x squared. We use the binomial theorem to expand the nth power of 1 plus 2x. Here, nc1 is equals to n, and nc2 is equals to n times n minus 1 over 2. So we have this expansion. And because we are told to expand this up to the term in x squared, so we end at the term in x squared and omit the other terms. And for the cube of 1 minus x, we omit the term minus x cubed here. We then multiply these two expansions. First, this one, when it is multiplied by 1 minus 3x plus 3x squared, we have these three terms. And 2nx, we multiply it by 1, you will obtain 2nx. And if you multiply this by minus 3x, you will obtain minus 6nx squared. And if you multiply this by 3x squared, you will obtain a term in x cubed. And finally, we multiply this 2n times n minus 1 x squared by 1, and we will obtain these terms. All the other terms will of higher powers of x. Finally, we have to collect the like terms so that we have the constant term equals to 1, and we have the term in x minus 3x here and 2nx. So the term in x is 2n minus 3x, and the term in x squared, we have 3x squared minus 6n squared and 2n times n minus 1 x squared. Add them up, you will have 2n squared minus 8n plus 3 times x squared. That's the binomial expansions up to the term in x squared. In part B, it is given that the coefficient of x squared in this expansion is 27. And with this information, we can find the values of n and the coefficients of x. By A, we have the coefficient of x squared is 2n squared minus 8n plus 3. So this is equal to 27. And we have a quadratic equation. So we can solve the quadratic equation, and n is 6 or minus 2. N is a positive integer. So minus 2 is rejected. By A, the coefficient of x is 2n minus 3. Because n is 6, so we have the coefficient of x is 2 times 6 minus 3, that is 9.